So chapter 6, section 2, we are going to multiply and divide radicals. I don't know why I put subtracting, but we're multiplying and dividing radicals. So we can combine numbers that have the same exponent and the same index for their radical, but we can't combine them if they're different. So here we see that this has a squared and this has a squared, so we combine the two and multiply the two numbers and then just square that number. But if we had, let's say, the square root of 2 times the cubed root of 2, we cannot combine these and simplify it anymore. So this, if we would just leave it as this would be like our final answer.
That would be the answer.
Uh-huh.
So the question is,
You can't, right?
Yeah, so the point here is that you can't combine them if their indexes or exponents are different.
Alright.
Okay.
So, number 8, letter A on the next one is same.
Okay, so for this one, can we combine these and simplify it?
No.
No.
So that's the answer.
So no,
Solution.
can't be simplified.
You have to solve it.
No, because we can't simplify this anymore, so we can't solve it. So this is our answer. So for B, can we combine these two?
Yes.
Yes. So we would have the cubed root, and we multiply the two numbers on the inside. So we would just multiply
-8.
-4 times 2, which would be
-8.
-8.
Oh, so much easier, not that embarrassing.
What is the cubed root of -8?
2.
What if it's negative though?
-2.
-2, because -2 cubed would be -8.
Oh, they go into
Yes.
each other, you multiply?
We multiply these two.
How'd you get -2?
Yeah.
That's what 3.
So the -8 splits up into -2 times -2 times -2. If our index is 3, how many numbers are we circling? 3 of them. So we circle all -2s and we take that out, and our answer is -2.
It has to have the same. Okay. Whatever. Go.
So it has to have the same index here in order to combine them.
Oh, okay. And your exponents have to be the same.
Okay, so for multiplying, here we see that our indexes are the same. So we just multiply the insides together. Same with the second example. Our indexes are the same. So we just combine them and leave it under the square root. For dividing, if we have a square root on top of a square root, we can combine it and just make the fraction on the inside of the square root. And that way we can simplify the fraction and then take the square root of it.
Yes, -2.
So we're going to do an example of multiplying first. So since we have the same index here, we can put it all under the same square root. So we have 72 times x cubed times y squared times 10 times x times y cubed. So we've just put it all under the same square root. Now we can factor all of this out and circle our pairs. Or we can just make separate square roots, and we can have one with the numbers. So we have 72 times 10. And then we could have one with the x's. So I'm just going to combine x cubed times x, which would be, if we have 3 x's here and 1 here,
4.
x to the 4. And then how many y's would we have?
Y to the 5th.
Y to the 5th.
You have to separate like this?
You don't have to, but sometimes it's easier to see it. Like I could just say all the factors here, all the factors here, all the factors here, and we could just write all the factors and circle our pairs. But it's easier to just to put all the numbers together and then find what the simplest form of that is and take it step by step. So how would we break down 72? What are 2 factors of 72?
8, 9,
9 and 8. And what are 2 factors of 10?
5,
2 and 5. Can we break down 9? 3 and 3. What about 8?
4, 2.
4 and 2. and 2 stays as a 2, and 5 stays as a 5. Can we break down anything else?
No.
4.
The 4.
So the dominant is 2.
Now, how many numbers are we going to have in each circle here?
3.
What's our index? The number out front here.
2.
2. Remember, if it doesn't have a number, it's implied that it's a 2. So how many numbers are we going to circle in each? 2 numbers. So we circle the pair of 3s. What else are we going to circle?
Pair of twos.
2.
The pair of 2s and the other pair of 2s. So what comes outside?
3, 2, and 2.
3, 2, and 2. And what stays on the inside?
5.
5. What do we do with the numbers on the outside?
We multiply them.
We multiply them. So we have 3 times 2 times 2,
12.
12.
Wait,
I just multiplied the 3, the 2, and the 2.
what do you do with the rest of the stuff?
We'll get there. That's next. So next, we have the x to the 4. So this is like saying we have 4 x's under the square root. So what are we going to circle? How many?
2.
We circle 2, the 2 pairs of x's. So what's going to come on the outside?
2x.
X squared, because we have 2 x's that come out.
And then we leave x inside. Oh, no.
And then the y's, we have 5 y's.
Circle 2, y.
So we circle 2 pairs. What comes outside?
Y. Y to the second.
Y squared. And what stays on the inside?
Y.
Y. So now everything that comes outside, we're going to write it outside. So we have 12 x squared and y squared. And then everything that stays on the inside, we're going to keep it on the inside. So what stays on the inside?
5
Times y.
and y.
Perfect. So this is our final answer. This one was a long one, but they're not all going to be this much work.
So you barely need to do work for the x to y.
Right.
So you just know it's 2.
Mm-hmm.
5y.
Next example.
Can I take a picture of that?
We do a lot though.
Okay, ready for the next example?
No.
Miss Thompson, do you think today was a waste of day?
Yeah, it was.
You divide.
Hold on.
It's correct. It's a lot easier if it just.
We're not there yet.
Yes, you are.
What did he ask? What did you ask?
Okay, next one. Terrell, what do we do first?
You divide on you have to put them together.
Okay, so we're just going to put them all under the same square root.
And then you divide 162 divided by 3.
Which would be?
God knows what.
I thought you knew, man.
54?
Yes.
Yes. And then this is like saying we have 5 y's on top
It's 5y, 54y to the third.
and 2 y's on the bottom. So these y's will cancel. And we're left with how many y's on top?
Y to the third.
Y to the third.
Oh, yeah.
Okay, so now we can take the cubed root of 54. So what are some factors of 54?
Oh, 9. No. 8.
8 and 6.
8 and 6.
No, we need 3.
8 and 7.
Wait, what?
9 and 6?
Oh, yeah.
Okay.
Don't we need 3 though?
Yeah, so we still have to break down the 9 and the 6. So what are 2 factors of 9?
3, 3.
3 and 3, and what about 6?
3 and 2.
3 and 2. Do we have any pairs of 3's that we can circle?
Yes, we have 1 pair of 3.
1 pair of 3's. So what comes outside?
3.
And then inside is 3 times 2, which is 6.
We're just left with 1, 2 on the inside.
Why? Oh, yeah,
Because we had to
did
circle
it.
all 3 of the 3's. Because the index of the 3 outside means that we have to circle 3 numbers.
3 and 2.
Yeah.
So now we have to do the cubed root of y cubed, which would be, we have 3
Y.
y's on the inside, we circle all 3 of them, and y comes out. So now we write our numbers on the
3y square root of 2.
2y.
outside and keep the numbers on the inside. So
This is so much fun.
3y and the cubed root of 2. Remember, if we still have this,
Wait, we should get.
if we still have to do the square root, we have to keep the index the same as what we started with. So since we started the original problem with a cubed root, we have to have our answer with the cubed root.
That's it?
Yep. So this is our final answer.
Too much work, though.
It is a lot of work.
Can you make it more simple?
More simplified.
Okay. What is the simplest form of the cubed root of 5x squared over 12y squared times z?
Can we flip things?
What do you mean flip it?
12 and 12.
Can you simplify 5 over 12?
No.
No, you cannot.
Exactly.
So there's
So it's just
no.
going to leave it the way it is.
Can we simplify any of the x, y's, and z's?
No.
No.
Oh, snap, you can't, so it's no solution.
So this would just be simplest form already. So we can't simplify this any further.
Hold on. Hold.
Okay, ready for the next slide?
No.
Girl, you still remember my word.
1.
Yeah.
So what do we do first here?
No.
Angela, what do we do first?
You divide it.
So we can write it all under 1 square root.
What the heck?
And now we divide it. So how do we divide the numbers? 20 over 45. How do we simplify that?
You can divide 2. You can divide by 2. Yeah, so you can do.
Does 2 go into 45?
No, because it's a 45.
No.
5.
5. We can divide them both by 5. So what are we left with on the top?
4 and 9.
4 over 9.
What the hell?
Can we simplify the a's? Can we cancel some of them out? Yeah.
A.
So we're left with an a, but on the top or the bottom?
Bottom.
On bottom.
On the bottom. And what about the b's?
2 in the bottom.
2 on the bottom.
And that's our answer?
Not yet. We still have to take the square root. So here, since we're still left with a fraction under the square root, we would just have a fraction on the top and a fraction. So we're going to separate it again. And a fraction on the bottom. And then we just simplify the top and we simplify the bottom. So what does the square root of 4 simplify to? 2.
3.
And now we just simplify the bottom. So the 9 breaks down into what?
3.
3 and 3. The a is just, we only have one a, and we have 2 b's. So what are we going to circle here?
3 and the B.
The 3's and the b's. So what comes on the outside?
3B.
3, b, and what stays on the inside?
A.
A. So this is our final answer.